Hi guys. For this one, we're going to be graphing absolute values and inequalities. We solved regular absolute value inequalities, and then we graphed linear inequalities, but we haven't really combined the two yet. So today, that's what we're doing. Now, in order to do this, we've got to cover a few basic steps. When we are graphing absolute values on the xy coordinate, which is what we are, we need to talk about the parent function. I know that magical phrase. Now, hopefully you remember the parent function for a linear equation, y is equal to x. Okay, this is the parent function for a linear graph, or a linear equation. All right, what this means is that for all equations that graph as a line, this is the most basic form of that line. However, absolute value is a different kind of line in its own right. It's a different kind of graph. Therefore, its parent function is also unique. And we have the parent function of y is equal to the absolute value of x. Okay, so we're going to go ahead and graph this so you can see what it looks like. And in order to graph this, I'm going to create a table. Okay, here are my x values, here are my y values. Now for the x values, I want to have both positive and negative values. Okay, and that's important. Okay, draw a little star. Need positive and negative values in the table. Okay, the reason being it's going to do some weird things on both sides, and so we need to make sure we're representing both halves, negative and positive. So I'm going to do the standard classic 5 points, so -2, -1, 0, 1, and 2. Now why do I pick these points, you ask? Because they're close to the origin, they're close to the y-axis, and they just make my math life easier. They're very nice numbers. All right, so what we're going to do now is we're going to take each of these x values and we're going to plug them into our parent function so that we can graph it. Now, if you're looking at this and you already know what I'm going to do, excellent. Go forth, do it faster, try to graph it, and then see if you get the same answer as me. If you don't know what I'm doing, then here we go. So here are my x values. I'm going to plug them into my parent function. So I have y is equal to the absolute value of -2. Okay, well, the absolute value of -2 is 2. Here we go again. Y is equal to the absolute value of -1. That's 1. And it just goes on down the list. Y is equal to the absolute value of 2. Whoops. And it's 2. Okay, these are my coordinate points. So now I'm going to graph these on my chart. So -2, 2. -1, 1. 0, 0. 1, 1. 2, 2. And here is my graph. Okay, this is the parent function. This is the simplest form of the absolute value. Okay, notice it's V shape. It's not a straight line. I mean, it has 2 straight lines, but notice the V shape. The V shape is important. You need to have that point. Okay, absolute value is a V. Also, notice that in my table, all of the values turned out to be positive. Now, if you think about it, that makes sense. Anything that comes out of the absolute value has to be positive. So it makes sense that my parent function is going to have all positive values. Now, as we graph this for the rest of the PowerPoint, we are always going to start here at the parent function. So it is very, very important, I'll put a star by it, that you either A, memorize this graph, or B, memorize this chart. This is the parent function chart table and the parent function graph. If you can memorize both, fantastic. But we're going to start here on every single problem for the rest of the PowerPoint, so it's important you know these 2 things. That being said, let's get started. Now, in order to graph absolute value, we need to talk about something called vertex form. Now, vertex form is a form of the line, just like standard or slope-intercept or point-slope. But vertex form is unique because it is specifically for graphing. Okay, specifically, vertex form tells us the transformations. Okay, the transformations of the graph. So if our parent function is the most basic of all these graphs, of all these functions, then the vertex form tells us where the parent function moves. Okay, kind of like the GPS. The GPS tells the car where to move. Vertex form tells the parent function where to move. This is vertex form, right here. Now, it changes its appearance based on which parent function you're dealing with. Today, we are dealing with absolute value. So please notice that we have the absolute value bars right here. Okay? My original parent function was y is equal to absolute value of x. Notice how we just added stuff around it. Now, our new letters are A, H, and K. We're going to spend a lot of time with these letters. A, H, and K. These letters will be in these spots at all times. Okay? They will always have the exact same job. So if you can remember what letter has what job, then you know where your parent function is moving. Okay? So let's go over this. A vertically stretches and compresses. Okay, so what that does is it makes the graph, it makes the slope, you could say, steeper or narrower. Notice how my V has changed. In the first one, it is steep. It's a very tight V. This would be a stretch. Okay? In the second one, this would be a compress. Okay? It's gotten flatter. Now, the other thing that A does is it can flip the graph. Okay? So it can vertically flip the graph. And we'll go over that a little bit later. Okay? Next, H. H is a horizontal shift left and right. So H will move the entire thing left, or it'll move the entire thing right. Last but not least, we have K. K is a vertical shift up and down. It moves everything up, or it moves everything down. So an example of this would be this bottom equation. F of x is equal to x minus 2 plus 2. So if I was going to write out all my transformations, well, I have A, H, and K. Here they are. Now, as I look, A should be right here. But since it's not there, since there's not a number there, I know A has to be 1. Okay? A is being multiplied to the whole equation. So if it's not there, it has to be 1. It won't be 0. Because if we multiplied 0 to the whole equation, then it would all just go away. Okay, so if it's not there, A is 1, nothing happens, it doesn't do anything. Now we come to H and K. Now H and K are the easiest to spot and the easiest to move, but you gotta be careful. Let's go K. K is the absolute easiest. It's just right there. Ta-da. K is 2. Now this means we are going to have a shift up. So the whole graph is going to move up 2 units. Whole thing moves up 2 units. Nice and easy. Now H is the one you got to be careful with. Notice my equation. I'm going to use a highlighter so you can see what I'm talking about. In my equation, let's erase this, I have that x minus h there in the middle. Okay, it is x minus h. Notice how the negative symbol is already there. So h is going to do this weird thing where it's going to be the opposite of whatever it looks like. So if in the equation it looks negative, h is actually positive. If h looks positive, it's actually negative. Here's why. My equation is negative, so I'm going to have x minus. Now, if h is a negative 3, if I were to plug, actually, no, I want to do positive 3. Let's do positive 3 first. If h is positive 3, if I plug a positive 3 into this x minus h, it's going to look like x minus 3. Now, h is positive, but because the negative symbol is already in the expression, when I plug it in, I get x minus 3. Let's see what happens when I plug in a negative 3. All right, I get the absolute value of x minus a negative 3. Okay, well, we can't have minus a negative. That just looks weird. So I simplify, and I get x plus 3. Okay, so it looks positive, but that's because it is negative. Okay, so the rule with h, whatever it looks like, it's backwards. Let's go to this equation over here. I have x minus 2. H is backwards. That means h is 2. So the whole thing shifts right 2 units. Okay? And there you have it. Now the vertex will always be h and k. H, comma, k. This is the coordinate point for the vertex. The vertex is the tip of our absolute value. Okay? So whatever h and k is, that's going to be our vertex. So if I look at my parent function, I'm going to draw it real quick on this chart. On this graph, I guess, better phrase. There it is. My vertex for the parent function is 0, 0. It's at the origin. That's my vertex for the parent function. Now, if I were to transform this graph to this one, I'm just going to take each one of my points and move it the exact same way that I talked about. So I'm going to take each one of my points and move it right 2, up 2. So my vertex is going to go right 1, 2, up 1, 2. There's my new vertex. Okay? And all of these points will shift right 1, 2, up 1, 2. 1, 2, up 1, 2. This one's going to go 1, 2, up 1, 2. Okay? All the points move in the exact same manner. And then this blue line right here is my new graph. All right. That was a lot going on. Let's break it down and look at each letter individually. First up, we got our easiest. We're going to use H and K. Now, you can ignore this bit right here. Now remember, H and K, move it left and right and up and down. H is left and right. Okay, now which way's which? If H is negative, so if you have a negative H, it's going to go left. If you have a positive H, it's going to go right. Okay? Same thing with K. K is also very simple. K is going to go up and down. Okay? If K is positive, the graph's going to go up. If K is negative, the graph's going to go down. Okay? So if we look at G of X, I'm going to look and try to spot all my letters. I'm going to write out all my letters. So my vertex equation is y is equal to a, absolute value of x minus h plus k. Now, as I look at G of X, there's nothing where a should be, so a is 1. It doesn't do anything. When I look for h, there's nothing where h should be. Now, because h is being added and subtracted, h is 0. Because if you add 0, there's nothing going to be there. Now, K is the easiest to spot. It's right there at the end. K is equal to 3. So when I graph my parent function, I'm going to move every single one of my points up 3. Okay? So I'm going to graph my parent function in black so that you can see it. There it is. All right, and I'm going to do this one in red. So g of x is in red. And I'm going to move each point up 3. So always move the vertex first. So we got 1, 2, 3. There's my new vertex. And every point, 1, 2, 3, goes up 3 as well. And there it is. There is my new graph. And I'll erase these so you can see it better. Okay. Now, when you're graphing this on your own, I do want you to represent both functions, the parent function and your new transformation. Okay, I want you to see that you're starting with the parent function and then you're moving it. All right. Now, let's do the h. Now, h is left and right. So, I'm going to go through all of my letters so we can practice seeing all of our letters. So, in this one, A, there's nothing there, so A is 1. H is right here. Okay, so H, remember H is backwards, so it looks like a -2, which means it is a +2. Last but not least, K, there's nothing back here, so K is 0. Now what this means is we're going to take our graph, and m of x is going to go right 2. Okay, this one went up 3. M of x is going to go right 2. So I'm going to do this one in blue so that you can see what I'm doing. It's in blue. I'm going to use the same parent function, only everything is going to go to the right 2 coordinates. So 1, 2, over here. There's my new vertex. And again, always kind of move your vertex first. That way you get a good idea for where everything else should be. And there is my new graph. Ta-da! This is m of x. And then this one up here is g of x. And as a reminder, m of x, g of x, these are just fancy names so we can tell them apart. All right, your turn. Here are 2 new equations. Ignore that bit. Go ahead. Label out your letters. So I want you to go through and what is A, what is H, what is K, what is A, what is H, what is K. Label your letters. Write out the transformation. Is it going left? Is it going right? Is it going up, down? How many? And then graph them. Okay? Good luck. Video's going to pause. When it plays, you'll see h of x. Then it'll pause again. When it plays again, you'll see n of x. Good luck. All right, and there's my answer. Notice how when I drew it on the graph, I labeled it as h of x. Okay, so I have colors. You can see quite clearly what I'm doing, but I'm going to assume you are not using colors. If you are, fabulous. If not, I need to be able to tell one graph from the other. So if you're given a name for your graph, always make sure you name it on the coordinate plane. Okay, good luck on n of x. The video is going to pause again. And there is the answer for n of x, or there's the graph for n of x. Okay, so remember, h, left and right, it's backwards. Whatever it looks like, it is the opposite. K, nice and simple, nice and easy. It is what it looks like. If it's negative, it's going down. If it's positive, it's going up. All right, here we go. Next, we have A. Now, A is special. A has 2 jobs. So in our vertex form, remember, we have y is equal to A times the absolute value of x minus h plus k. Now, A, like I said, has 2 jobs. First of all, it's a vertical stretch / compress. Okay? Vertical stretch and compression. Now, a stretch, like I said, is going to make the graph skinnier. It's going to make your V a very, very narrow V. A compression is going to make it a wide V. Okay? Now, which numbers do this? Well, all numbers that are greater than 1. So, if A is greater than 1, you're going to get a stretch. All right? If A is in between 0 and 1, you're going to get a compression. Okay? So basically, if you have a fraction, it's going to be compression. But be careful with that fraction, because if I have 5 over 2, okay, well, that's 2.5. That's greater than 1. Okay, so if A is greater than 1, it's going to be a nice narrow V, a stretch. If A is in between 0 and 1, it's going to be a compression. Now that's A's first job. Let's talk about A's first job for this first problem, and then we'll talk about A's second job for P of X. All right, so here we go. Now, here we go. We have A. Let's list out our letters. So I have A is equal to 2. H is nothing, so that's 0. And K, there's nothing there, so that's 0. There are our letters. So since A is 2, this is going to be a vertical stretch of 2 units. Now, how do we do that? Excellent question, I hear you ask. What we're going to do is we are going to create our parent function table. I told you to come back. It's back. So -2, -1, 0, 1, and 2. How can I do it this fast? Well, I have memorized. If you have this memorized, you'll go fast too. Now, when you are applying the vertical stretch, notice how A is being multiplied to my equation. So it's A times the absolute value of X minus H. Times, multiplied. We are going to do the same thing. We are going to multiply A to our table. But pay attention here. We are only multiplying it to the Y values. Okay? So I'm going to multiply A to my Y values only. So when I redo my table, the X coordinates are going to stay the same. -2 stays the same, -1, 0, 1, and 2. All of my X coordinates stay the exact same, but I'm going to multiply my Y coordinates by 2. So 2 times 2 is 4. 1 times 2 is 2. 0 times 2 is 0. 1 times 2 is 2. 2 times 2 is 4. All right. Now, the reason why we're multiplying to the Y coordinates is because this is a vertical transformation. Okay, it's a vertical transformation, so it's only going to affect the vertical coordinate. The vertical coordinate is Y. It doesn't do anything to X. X stays the exact same. Okay, so let's look at what this does. When I graph this, graph my parent function first. There it is. Okay, again, my X coordinates are going to stay the same, but let's see what happens when I plot my Y coordinates, my new Y's. So my vertex, it stays the same. Nothing changed with my vertex. It's still at 0, 0. But I go -1, 2, -2, 4, 1 and 2, 2 and 4. And there we go. Look how much narrower that made my graph. I have a very narrow graph because I had a vertical stretch. And there it is. Okay? Now, that's A's first job. The first job is vertical stretch or compress. A also has a second job. Okay? A's second job talks about the sign, and it focuses only on the sign of the number. So if I look at Q of X, I can see that A is positive. If I look at P of X, A is negative. Right? Now, on that first slide, I mentioned that A does a vertical flip. Here we go. If A is positive, the graph is going to be focused up. It's going to be pointing up. If A is negative, the graph will be pointing down. Okay, so let me write that out. If A is positive, the graph goes up. If A is negative, then the graph goes down. My V flips upside down and it is pointing down. Now, the nice thing about multiplying a to the y coordinates is you'll be able to see this, okay? It'll just happen due to multiplication. But the nice thing about knowing that a points it down if it's negative is that you can check for math errors just by looking. Okay, if you're trying to figure out what the graph is and you see that a is negative, you know the graph is going to be pointing down without even looking at it or without even doing any math. All right, so let's do p of x. Here we go. All right, here we go. I have that work. A is a negative 1/2. H is nothing, so that's 0. And then k is nothing, so 0. They don't do anything right now. Okay, so I'm going to write out my transformation. I have a vertical compression. I'm missing a letter in there. There it is, compression. And a vertical flip. Okay, A has 2 jobs. So I have the 1/2. So that's going to be a compression, and A is negative, so that's going to be a flip. So I'm going to draw my parent function. Negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2. X and Y. And now I'm going to multiply the entire thing, or I'm going to multiply Y by my A, which is going to be negative 1/2. So all of these values get multiplied by negative 1/2. In my new table, remember the x's stay the same. I'm running out of room here. And let's do this. 2 times negative 1/2, well, that's a negative 1. 1 times negative 1/2 is a negative 1/2. 0 times negative 1/2 is still 0. 1 times negative 1/2, and you get the point. It's just going to mirror its way down. 2 times negative 1/2 is a negative 1. Okay, so you can see our numbers, okay, they're all negative now. So they're all pointing down. I'm going to use the exact same parent function. Notice my vertex didn't move. We're still on the origin. Okay, but now I have negative 1 and 1/2 right there. Negative 2, negative 1, negative 1, negative 1/2, 2, negative 1. Here is my new graph. And you can see it's now flipped on the other side of the x-axis, and it's wider than my black graph, my parent function. And there's p of x. Okay? So A has 2 jobs. Make sure you write this down. Make sure you have these examples. Okay? As long as you do your multiplication correct, it'll all work out. All right? Because when you multiply by a negative number, the values will, of course, change. Now, so far, we've only done one value at a time, one letter at a time. Let's see what happens when we put 2 transformations together. Now, when you do this, the exact same rules apply, but you're just going to go in order. So my vertex form is y is equal to a times the absolute value of x minus h plus k. You're going to go in order down that list. Okay, so you're going to do a first, then h, then k. Okay, that way you don't get confused. That way nothing gets messed up. So first off, we are going to find our transformations. So I'm going to list out my a, my h, and my k. Here we go. A is always going to be up front, and that is a negative 2. Okay? H is always going to be inside with x. It looks like a negative 1, so I know it's a positive 1. And then k is always on the outside, and it is exactly what it looks like. Okay? Now that I know my letters, I'm going to describe my transformations. So A, I know, is a vertical stretch and a vertical flip. Okay, it's going to do 2 things. One thing for the number, the second thing for the sign. H is positive here, so it's going to go right 1. And then K is positive, so it's going to go up 1. Up 3, my bad. There we go, up 3. All right. Now that we got everything written down, we're just going to go in order. Just going to go in order. So first up is A. Let's make our table. Okay, so -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. There's our table. And we are going to multiply the y coordinate by A, which is -2. All right, the video is going to pause. When it plays again, you'll see the table. Okay, there's my table. How'd you do? All right, so now what I'm going to do is I'm going to graph. I'm going to graph my parent function first, as always. I'm going to do a dotted line this time. The reason why I'm doing a dotted line is because things are going to get pretty crazy with 3 transformations, and I want as few things on my picture as possible. So let's graph our A transformation first. So my vertex didn't move anywhere. -2, -4 right there. -1, -2. And the same thing on the other side. All right, again with the dotted line. The important thing here is that we keep track of our points. Points are important. All right, that was A. Now let's go to H. And honestly, if you want to do H and K in the same movement, go for it. I'm going to do it in the same movement. I'm going to go H first, then K. So every single point, I'm going to move to the right 1 and then up 3. I'll change colors to blue so you can see what I'm doing. Start with the vertex. So I'm going to move my vertex right 1, up 1, 2, 3. Okay, this point, right 1, up 1, 2, 3. Right 1, up 1, 2, 3. Right 1, up 1, 2, 3. This point, right 1, up 1, 2, 3. Okay, that's why making sure you have nice, neat, clean dots is so important, because you're physically moving the dots according to your letters. Now I'm going to connect my dots with a nice bold line so that it's easy to see despite all of our notes. Label it G of X, and we're done. Okay, there is a graph that was transformed with all 3 transformations. Okay, guys, that's the end of the video. If you have any questions, please let me know. Make sure when you're doing this that you just stay nice and neat and go in order. Remember, these letters, they stay in the exact same position and they do the exact same job every single time. So if you can remember those patterns, you can do any problem I give you. That's it. I'll see you next time.